aside from the example of rewriting a repeating decimal as a fraction, this word problem, this is the other type of word problem that's typical for geometric series. So drop a bouncing ball. So we can say here, if you want to classify this, what are the word problems associated with geometric series? Number one, bouncing ball problems. And number two, rewrite repeating decimal problems. So we can just write repeating decimal problems. So we use the repeating decimal. Remember the decimal that we were working with was 0.9 repeating. So since we already went over a repeating decimal problem, I wanted to end this section just by going over a bouncing ball problem. And here's a typical one. So now I've kind of drawn a sketch to explain what's happening. This is our ball. We'll pretend, I don't know what kind of ball it is, a golf ball. Probably not a golf ball because golf balls don't bounce that much. But whatever kind of ball this is, we're told that it's dropped from a height of 6 feet. So the initial height is 6 feet. And then each bounce has a height that is 3/4 or 75% of the previous height. So what is 75% of 6 feet? 75? Yeah, 0.75 times 6. 4.5. 4.5, all right. So this is going to be 4.5 feet. And now this is going to be 4.5 feet because we're considering vertical distance. You have to take into account the ball traveling up and then also traveling down. And then 75% of 4.5 and 75% of 4.4.5. Or, you get the idea of what we're doing here. So the question is, how do we express the height traveled as a geometric series? We essentially want to say that our height, or the total height, equals, or total distance. But we don't want to say distance because the ball isn't just going to, there might be wind impacting it so that it's moving laterally as well as vertically. So total vertical distance. That's why we need to say total vertical distance equals, well, clearly it's going to be 6 plus 2 times 4.5 plus 2 times, now how did we get this 4.5? This 4.5 was actually 0.75 times 6, right? So our next height needs to be 0.75 of 0.75 times 6, right? Because it needs to be 75% of 4.5, but 4.5 is 75% of 6. So we need 75% of 75% of 6. Whatever that is would go there. And then plus 2 times, and we just keep repeating it, right? So it needs 0.75. And notice instead of, this is the same thing as 0.75 squared times 6. This is 0.75 times 6 to the first power. So here we just have 0.75 cubed times 6. Okay, so it looks like our vertical distance traveled, total distance, is going to be 6 plus 2 times the sum of 0.75 to the n times 6. And now n starts at 1 and stops at infinity. You know what I mean when I say stops at infinity. It doesn't actually stop at infinity. But, so I guess the important part is that it starts at 1. And so notice that r is equal to 0.75. So clearly, the absolute value of r is less than 1, so our series converges. So our infinite series converges. Let me switch to a new page. So say since the absolute value of r is less than 1, our series here, which is 0.75 to the n times 6, converges. Now notice that r being less than 1 makes sense. If you were to have r equal to 1 or r greater than 1, that would mean that each time that you bounce the ball, right, each time that the ball bounces, it jumps, it goes higher than it did before, right? So if r were over 1, which means more than 100%, that means each time that you bounce the ball goes higher. And so when you go to add up the distance that's traveled, there's no way it's going to converge because the number just keeps getting bigger and bigger and bigger and bigger and bigger and bigger and bigger, right? So that ball is never going to stop bouncing because each time it's bouncing higher than it was before. Okay. So now that we know r, so our height or distance, we said was equal to 6 plus 2 times this sum from 1 to infinity. And I'm just going to move it around. 6 times 0.75 to the n. This is, well, let me rewrite this, n equals 1. I want to have this as, I want it to start at n equals 0. So I'm going to subtract 1 from n over here, and I need to add 1 over here. Okay, so now I can rewrite this as equals 6 plus 2 times the sum, n equals 0 to infinity, and then I have 6 times 0.75 to the n plus 1. Okay. And I can pull off a factor of 0.75. Okay. And then still have 0.75 to the n. Now, 6 times 0.75 is 4.5. So we still have 6 here. So I have 6 plus 2 times the sum of 4.5 times 0.75 to the power of n. Okay, so I've got my a, I've got r, and I'm ready to use my formula to say that this is equal to 6 plus 2 times, I need a over 1 minus r. Remember, a is 4.5. And r is 0.75. Okay, so what is 4.5 divided by 0.25? That's 18. Okay, so this is 18. So that times 2 is going to be 36. Plus 6 is going to give me 42. So equal to 42 feet is the total amount traveled by that ball. That's it.